program contains experiments which are performed by professionals. These tests are dangerous and may involve the use of hazardous materials. They should not be performed or imitated under any circumstances. The light bulb transforms electricity into a heat so intense it glows. It heats up to light up. It's been proven time and again. A great way to find out how something is put together is to pull it apart. One of our specialties. Once the light switch is thrown, the current immediately activates the bulb. There are two electrical contacts, one on the side of the base and the other at the base of the bulb. Copper and nickel wires take the current to the filament where it all happens. These light bulbs are incandescent, which means they give off visible radiation when they get hot. Actually, the filament should get all the credit for that. To turn off the light bulb, the switch simply cuts the current. The filament is pretty special. It's made of tungsten and can take a lot of heat. And when we say a lot of heat, it has the highest boiling point of all the metals. Examine the filament closely, and you see it's actually a lot longer than it looks. It's spiraled and wound over onto itself. It took manufacturers until 1937 to figure out how to perfect the delicate process of winding the tungsten filament. Anyone can easily pull it to about 8 inches in length. The filament may look flat, but closer examination shows it's actually an even smaller series of spirals. To be precise, 1,130. When you get it all unwound, the tungsten filament of a 60-watt bulb is 21 inches long, and yet, sitting cozily inside a bulb, it measures only 1 inch. All those twists have one purpose: to fit more filament in a small space and get the maximum amount of light. When little subatomic particles called electrons get busy, the electrons happily dance along the copper and nickel wires. But once they get to the tungsten, the fun stops. The filament is so thin, it resists the electrons, and as they butt heads with atoms, they vibrate and heat up. The filament gets so incredibly hot, it gives off light. So you've got electrical energy converted into thermal energy, or heat, which in turn is changed into luminous energy, or light.